Hey everybody, brace yourself. Factoring just keeps escalating and just keeps getting better. And here we go with a situation now that is going to be potentially ugly when you first see it, but turns out to be marvelously beautiful once you understand the intricacy of what's happening. We're going to be factoring grouping. And you can think of it as where factoring with the greatest common factor was like undistributing. This is like double or triple undistributing, depending on how large a polynomial you're factoring by grouping. Now we are going to restrict ourselves to just looking at four-term polynomials for this particular process. So what I'm about to show you, how to factor by grouping, is only going to apply to these four-term polynomials. And we're going to factor them into a binomial times a binomial. And as you might guess, if I were to multiply out these two binomials, I would get 12x cubed plus 3x minus 8x squared minus 2. And so our job is to take this and turn it back into this right here, to double undistribute. You'll see what I mean by that more in just a second. Now, a word of caution about this. Because these are long drawn out processes, and yet I want to give you as many examples as possible, a lot of times what I'm going to be doing is I'm going to be, when I can, shortcutting some of the work and speeding up the video to show some of the more busy processes. You may have to slow down and pause and take additional time on that, but just to keep the video at a reasonable length, know that I'm going to have to do some of that. Again, you take it slow, you write down everything, don't do anything in your head, use as much paper as necessary. Remember, writing the stuff down frees up space in your brain. There's no reason not to do that, but I will be sort of speeding through some of the parts that we already know how to do to show you the parts that you don't know how to do. So let's start with just a refresher on multiplying polynomials. So when I had a binomial times a binomial, remember what I did was that I ended up distributing each term of the first polynomial throughout the entire second polynomial. So this 4x went right there, and then I would take the next term and I would distribute that throughout the entire polynomial. And when I would multiply this out, that would give me my final answer. 4x times x squared would of course be 4x cubed plus 4x minus 2x squared minus 2. And now I've multiplied that thing out. So it's just the distributive property twice. And I want you to note this right here. X squared plus 1. X squared plus 1. It's the same. It repeats. Now, take all that, kind of push it to the side in your mind. Don't make it go away. But now let's change gears for a second. I see this four-term polynomial. So I see this four-term polynomial, and the only way I know how to factor a four-term polynomial is to look for a greatest common factor. So that means I have to take each term in this, and I have to factor each term in this looking for a greatest common factor. And the unthinkable happens. They don't have a single thing in common. So 2 in this one, well, that one doesn't have a 2, so it doesn't work. There's a 3. That one's got a 3. That one doesn't, and that one doesn't. Well, this one's got an x. That one's got an x. That one's got an x. That one doesn't. There is, again, not a single thing that all four of these have in common, so there's no greatest common factor, so I can't factor using that. Something else has got to happen, right? So here we go. I say one of the most powerful ideas in mathematics. What I mean by that is the most powerful idea in mathematics is to take a problem that you don't know how to solve and to rearrange it, to look at it from a different angle so that it resembles one that you do know how to solve. And so in this case, to make this something that we know how to solve, we're going to group it. So we'll group those two terms together and those two terms together. And now what I'm going to do is I'm going to say, those two terms right there, let me see if I can factor them. And those two terms right there, let me see if I can factor them. And so we go through our process of finding out if we can factor them using a greatest common factor. And so it turns out this one I could pull out a 3x. Notice there's nothing left here, so I put a 1 right in there to hold its place, because 3x times 1 will give me that 3x back. And so I look over here. Maybe I can factor those. And it turns out, sure enough, I can factor those. And now look at this amazing thing that's happened. Just like when I multiplied those, I got the same thing in both those parentheses. And so now I'm at this very neat place where I can factor by grouping. I make groups of two terms each. So I group these terms and these terms, just do them in the order they come in. It'll work out, trust me, I'm making all the problems. So we group them up. We factor each group using a greatest common factor. So in this case, the first group looks like 3x times 4x squared plus 1. And my second group looks like negative 2 times 4x squared plus 1. And when I do that, I find that the parts that are in parentheses are exactly the same. And so now I'm going to rewrite that as a double distributive property type thing. 4x squared plus 1, well, I'm distributing a negative 2 through that, and I'm distributing a 3x through that, and I can just write that in parentheses. The 3x goes there, the negative 2x goes right there, and look at this really beautiful result, and that we end up having factored that. So now let's take a look at some examples. Just as we've done before, I'll do one, and then you do one. So here we go, and bear with me, these are long, they take patience, they take perseverance. We're going to do several of these, so buckle in, you got this. First, write it down. Once you've got it written down, what we're going to do is we are going to check first. And this part, it takes forever, but every time you've got to check and see, is there a greatest common factor? Can I factor this using my older technique? So in this case, I know I can't, and here's why. 10 is 2 times 5. That can't be divided by 2. That can't be divided by 5. They don't all have a p. They have nothing in common between all four of them. So I know I'm going to have to group them. So I group these, and I group these. And what you're going to do now is that process from the last video. You're going to find the greatest common factor from this set and this set, and use that to do each one individually. So there you can see I've done the first set. I got 5p squared as my greatest common factor, and then that's what I had left over. You can multiply to verify that it works. Now we've got to do the same thing for the other one. So my common factor was 6, and I have 2p minus 7 left over. And again, look at the magic that happened right there. You end up with the same thing. So this is like I'm taking 2p minus 7 and I'm distributing a positive 6 and a 5p squared through both. And so what you can see is that this is now turned into multiplication of a binomial times a binomial. it's factored. So let's take a look at yours and make sure we get a similar result. And there you have it. If you're really curious, you can multiply those out and in fact verify that when you multiply those two binomials together, you end up back with your expression. Very nicely done. So next up, we're going to do it again. These are long. There's no way around it. Hang in there as best you can. So 2x cubed plus 14x squared plus x plus 7. We must check and see if we can use a greatest common factor first. This term right here, the only factor is x, and I don't have an x in anything else, so there's nothing I can pull out. So a greatest common factor is not going to work. So we group them and we factor. Now that I have factors, or have found the greatest common factor for the first group, let's do it for the second, which is going to be noticeably easier because x is prime and 7 is prime. So what we do, there's nothing in common between these. So the only thing I can say they have in common is a 1, because I can always say that there's a 1 in common, and when I do that, well, I didn't move anything from there. It's still x plus 7. So if I have something like that, you can always just put a 1 out there. Again, 1 times x plus 7 doesn't change anything, but it does let us set up our grouping. And now we see, like magic, that same 1 there. So we rewrite it. We have our x plus 7, and we're distributing a positive 1 and a 2x squared, just like that. And so we can see that we have a binomial times a binomial. You can multiply them all out and see if it works. So now let's check yours and let's make sure we're on the same page. And there you can see I have the binomial that, or two binomials rather, that when I multiply them, give me your expression back. Whew. It's a lot of work, right? The good news is that once you can do this, you have the largest of our factoring processes down. Everything else will just be turning problems into problems that look like this. So here we go. Let's look at a third example. Oh my goodness, these things are just getting ginormous and seemingly out of hand. But notice this, these are some big fat numbers we've got in there. A neat thing can happen on this. You know how I've told you on the last two that as I write this down, I really have to check and see if there's a greatest common factor? Well, guess what's going to happen on these guys right here? If I take this out and I write down all four of the factors on this, it turns out that there is, in fact, a greatest common factor that I can pull out of all of these. It turns out I can pull an 8 out of every single one of these terms. So I can write an 8 here on the outside, and then on the inside I am left with 35 r cubed. Here I'm left with minus 5r squared. When I pull out an 8 from this one, my word, that's going to be 56r. And from that one, and 8. And so that whole process, which I shortcutted there, because remember, I've been doing this a while, you'll actually have to check and see every single time. And there's no way I can pretend to you that this is not time consuming. There's no way I can pretend to you that it isn't a pain in the rump to check every time, and yet your responsibility as a student is to check every single time. So now that I've done that, I have factored this thing technically speaking, but I have to check and see if this on the inside can be factored even further. And it turns out that by factoring using a greatest common factor, or by grouping rather, I can in fact. So now I have to take this piece inside and I'm going to factor it using our new grouping technique. So I take 35r cubed, which is 5 times 7 times r times r times r, and negative 5r squared, which is negative 1 times 5 times r, and I can see very quickly that they have a 5r squared in common, and it leaves me with 7r times, minus 1. And I have to be very careful because there is something I left out from one step to the other. Notice that all of this is actually still inside those parentheses. So when I go to write this out, that 8, it's still lingering there on the outside. It didn't go anywhere. Now I've got to do over here a 56r and negative 8. And notice again, they're the same. That has to happen in order to group. If they're not exactly the same, we can't do our factoring by grouping. So now I'm ready to rewrite this, and look at this ridiculousness. The greatest common factor goes first. And then my first binomial, 5r squared plus 8. 5r squared plus 8. And then 7r minus 1. Now I have factored that out with a greatest common factor, no less, and then done my factoring by grouping. So let's take a look at yours and see how that worked out. Long, involved, but ultimately quite beautiful that we could break down something that complicated into something such as that. Let's look at one final example where this is as wrong as things can go. So if you can handle this situation right here, then you've got it all covered. We're going to check and see if we have a greatest common factor. Just like we always do, I can tell you in this case that we do not. You will not always have that help. Again, you must check. So we're going to factor by grouping, just as we've been doing. So you break it down into its pieces, and here we go. Let's factor the first set right here. And then I'm going to factor the second set. And now I look at the disaster that has befallen me. All the beauty of factoring by grouping is that we end up with the same thing inside the parentheses. And we didn't. Notice that the 5 is positive here, negative here. and the 4 is negative here and positive here. So we need some way to overcome this, to turn this into grouping, something that we can solve. And it turns out it's easy so long as we're in a situation where the signs are flipped. All we have to do is change the sign of this thing that we factored out. So where it was a positive 3, make it a minus 3. And what that does is that changes the sign of everything inside here. So that plus 4 then becomes minus 4, and now things match. So just by switching the sign, technically speaking, we're factoring a negative 1 out of this. But just by pulling that negative sign out of there, now they match, and I can set this up as my beautiful, perfect factoring by grouping. By the way, if you want to look it up, it's not just me that refers to the beauty of mathematics. Anybody who really gets sucked into this subject sort of understands the amazingness of what's happening here as far as just order falling out of seeming chaos. So there we go. There's that one. And let's take one final look at what yours looks like. And there you have it. We have finally factored. Behold the madness. This is factoring. This is the bane of most Algebra 1 students' existence. However, if you can do this, then you have really accomplished something. This is not a simple or straightforward process. It requires lots of work, lots of perseverance, lots of order of thought, and it will take practice. You're not going to be great at this instantaneously, but you will be great after you've practiced for a long while. So to recap, here's what we've done so far. We know how to factor a monomial, get the prime factorization of a coefficient, rewrite the variables without exponents. We can factor using the greatest common factor. We factor each term of the polynomial, see what they have in common, write it as the distributive property. And now we know if we've got 4, count them, 4 terms in that polynomial, we can group the first 2 and the last 2, pull out a greatest common factor, and rewrite it as polynomial multiplication. Thanks for hanging in there. I know this was a lot to take in. Best of luck to you.